the second video going over this table. In the first video, we talked about how to know when there's an asymptote. There's only asymptotes in rational, exponential, and log functions. So we filled in all those not applicables in the table, and we named the type of each of the functions. So now we're going to look at finding the vertex or center, if there is one, or the asymptote, and then giving the domain and range. So here, in this first exponential function, again, you have to remember the parent function of exponential, what it looks like. Remember, change my table. Hang on. I don't know what's happening with my stuff. That's weird. Okay, but it's the one, I'll just arrow it. Like, let's say this is my XY axis. It comes up and exponentially increases in that direction. Okay, but what's happening here? No reflection over the X because there's no negative A. No reflection over the Y because there's no negative B. But there is, and we're not worried about a vertical asymptote, so we really don't care about a left or right shift, which is happening here, but you don't need to know it to be able to answer these questions. Because the domain for exponentials, no matter what reflection takes place, the domain is always all reals. And then I'll put my cursor up here. Hang on, I'm trying to figure out what's going on here. All right. So the only thing we're worried about is a vertical shift, which comes from this K, this plus or minus on the outside of the function. So this graph is shifted down 2, which means the horizontal asymptote is at -2. Which again, we put in the table, horizontal asymptotes go through the y-axis, so they're y equals. Vertical asymptotes go through the x-axis, so they're x equals. So there's an asymptote at y equals -2, a horizontal asymptote, and this graph is not reflected, so it's still above that. So the range is from -2 to infinity. And it does not include the -2 because it's an asymptote, so it's a parenthesis. I'm going to skip this one for now. I'm going to go through more that don't require any algebra work. All right, so for this one here, this is a rational function, and we know it's going to have both a vertical and horizontal asymptote. The K affects the horizontal asymptote. It's shifted down 3, so I know that this is y equals -3. And then the vertical asymptote comes from whatever would make the denominator 0. Okay, so this 3x minus 6, I would have to set it equal to 0 and solve. So I would have to add the 6 over and then divide by the 3. So that would end up being 2. So x equals 2 is the vertical asymptote. Now the center, we're just asking where are those intersecting? So you can see the x is 2 and the y is -3. So that's the point where those asymptotes intersect. So those are the only breaks in the domain and range. Okay, so picture it or sketch it if you need to. A vertical asymptote is up and down. So when x is 2, that's breaking up the domain. It's a break in the x values. So the domain is everything but 2. So you can write that as -infinity to 2 union 2 to infinity. So it's everything except 2. The range would be everything but -3 because the horizontal asymptote is breaking up the y values. So we write it the same way with the union. All right, for this one, we have the cubic function. No b value or a value to affect it, only shifts. So this, remember, inside is opposite. So this is actually right 3. So it's +3, +2. So for this cubic function, this 3, 2, now remember, this is not a vertex, this is the center. This is the point of inflection of that cubic. But we know the general shape of a cubic, domain and range are both all real numbers. And let's see, here another exponential. So again, it's going to have just the horizontal asymptote. So we're only worried about where that's shifted. So and it's down 3, so it's at y = -3 as well, which affects the range. It affects the range. Now this is not reflected because a is there's no negative a value here. So it's just the same general shape of your exponential. It's just shifted right 2 and down 3. So the range is going to be from -3 to infinity. The domain, again, the domain for an exponential is all reals. We just said for a cube root function, the domain and range were all reals. The same thing for a cubic function. The domain and range are all reals. It doesn't matter how it's stretched or shifted or compressed or reflected. It's always going to be all reals for cube root and cubic. So then this one, we just need the center, that point of inflection where it changes concavity. So nothing inside with the x that's being cubed. So that would be a 0. And then down -2, -2. All right, now this is a rational function. Again, x is in the denominator, so it's going to have both x and a vertical and a horizontal asymptote. So remember, what would make the denominator 0? In this case would be 0 because there's nothing added or subtracted or multiplied down there. Okay, and then this k is the y, so that's 3. So remember, it's when x is 0 and y is 3. Okay, that's the point where the asymptotes intersect. So again, this is breaking up my domain. So my domain is everything but 0. And this is breaking up my range. So my range is everything but 3. Now for a log function, actually, I'm going to go ahead and answer this cube root since we just did a cube root and a cubic. We said domain and range will be all reals. And then this one, though, oh no, the negative's outside. That's not going to affect this. So this is the opposite. So it's -3, -2. So that's the point of inflection. And you're not going to be asked for the point of inflection on this test for a cube function or a cube root function. So you don't need to worry about that. All right, so we'll go back to this log one. So here, a log function, that's the inverse of the exponential. So remember, the exponential came left to right, increasing rapidly, and it had the horizontal asymptote. Log has a vertical asymptote, and it comes up along the right side of that and goes out to the right. Okay, so this log, the range is always all reals. Just like an exponential, the domain was all reals because they're inverse. And so remember, x and y switch, so the domain was all reals. So for this one, it's the range. Now, for exponential, we were only worried about the vertical shift up and down, moving the asymptote. Now we're worried about the left and right shift, the horizontal shift, because it's a vertical asymptote that we have. So this is being shifted to the right 3. So this is actually at x = +3 that the asymptote is. and there's no reflection here. So it's from the asymptote to infinity, so 3 to infinity. And again, we don't include the 3 because it's an asymptote, so it's a parenthesis. All right, square root function. Okay, square root function, this is the general shape of it, like this. It usually starts at the origin and shoots out into quadrant 1. So we need to get the center of that, or the vertex of that. So inside, there's a b value. So we have to set what's inside. We did this in our notes, equal to 0 and solve for x. So we'd add the 6 over and then divide by the 3. 6 divided by 3 is 2. So x equals 2. And then for the y value of that point, it's this k value, this shift. So it's positive 2. So that's at 2, 2. So what this graph looks like now is it shifted over 2, up 2. No reflections or anything. No negatives on either of those. And so then it's still going in that same direction. So the domain is from here, this x value is 2 to infinity. Now this time we include the 2 because it is a point on the graph, so we use a bracket on the 2. Same thing for the range, that also happens to be 2 because the y value is at 2 as well. And it goes up forever. And again, we include that point. So that one's a bracket as well. I'm going to go ahead and do this bottom one since we're talking about square root. So this one is right 3 up 2, so it should be positive 3, 2 for where that vertex is, meaning, and there's no reflection happening here, so it's still going up and to the right. So that means the domain would be from 3 to infinity, including the 3, and the range would be from 2 to infinity, including the 2. Okay, and then we talked about log just a second ago. It's the inverse of exponential. It has a vertical asymptote, so we're worried about the horizontal shift, which in this case is left 3, because it's the opposite. So x is negative 3. So that means that, and there's no reflection, so it's still going to the right of that asymptote. So it would be from negative 3 to infinity, and we would not include the negative 3 because it's an asymptote, so that's a parenthesis. But again, range for logs, all reals. No change there. I guess we'll just work our way up from the bottom of this table. So here we have cubic. We said for cube root and cubic, all reals for domain and range. And then we're just looking for that point of inflection. So it'd be the opposite of what's inside here. So negative 3, negative 2. And then I'll do this absolute value. So again, absolute value similar to what we did with the square root right here when I said we take what's inside and set it equal to 0 and figure out the x. We're going to do the same thing here. We're going to take what's inside, the 2x minus 6, equal to 0. So I would add the 6, divide by 2, so that would be 3. So the x value would be 3, and then the y value comes from the k value, the number added or subtracted on the outside, so just a 2. So positive 3, positive 2. Now, this is reflected. There's a negative here. So this absolute value is upside down like this, and that's the point we just found at 3, 2. Okay, so my range is actually coming from the bottom up to that point. So instead of 2 to infinity, it's negative infinity to 2. But we still do include the 2. And then the domain for absolute values, all real numbers. Doesn't matter, the reflection. All right, so now we're going to do these two quadratics that are in standard form. There's one on the front side and this one here. So I'm going to pull up just a whiteboard here for us to work on. that's not what I want. I'm still learning about whiteboard. So every time I open it, like the stuff I did last time is there. Let's see if I can see a new whiteboard. Oh, okay, create a new whiteboard here. There we go. It's easy enough. All right, so I'm going to write these down and then we can come back and put them on the table. All right, so this one is negative 4x squared minus 24x minus 38. And the other one is 5x squared minus 20x plus 17. All right, so let's take a look at these. So if you do, we learned completing the square to rewrite from standard form to vertex form, but we only learned that and practiced that when the a value here was 1. Okay, so in this type, if that a value was 1, you could just do completing the square, get it in vertex form, and then you would be able to see the vertex just like we did on all of the other ones there. But here with this value, we want to do the negative b over 2a. Okay, this is probably going to be the easier method for you. And this is how we're going to find x, the x value of our vertex. Okay, so I'm going to take negative, and then b is already negative, but that also gets plugged in, 24 over 2 times a, and a is negative 4. So then I have positive 24 over negative 8, so that's negative 3. So the x value of the vertex is negative 3. And so now I need the y value. So I'm going to plug it back into this. I'm going to say, okay, plug in a negative 3. And calculate this out. Now, we said this is on the no calculator portion of the test. You can do this math without a calculator, but I did activate just the basic calculator, so just to save time, really. So you will have like add, subtract, multiply, divide calculator. You just won't have a graphing calculator. But so when I multiply this out, so negative 3 squared is positive 9, and then we multiply that by negative 4, so it's back to negative 36. Negative times a negative, so this is plus, and 24 times 3 would be 72, minus 38. So again, you can do this by hand like I'm doing, or you will have a calculator that you're able to input to do these operations, but this comes out to negative 2. So that's the vertex, which I'm going to go back to the table and fill this in. Negative 3, negative 2. This was for this one on the back. So that means this is a quadratic, it's a parabola. It is negative, meaning it is, I don't know why that's moving, that's so weird. The negative means the parabola is opening down. Same thing when we had the negative here on the absolute value. So this is the vertex. It is a maximum point. And so I would say my domain, all real numbers. Quadratic, always domain, all real numbers. But my range at negative 2 is what I had defined. And so my range is from negative infinity up to negative 2. Now this time I do include the negative 2. It's not an asymptote, it's a point on the graph. All right, so we're going to do the same process here for this one. Now this one I do know is positive a, so I know it's going to be opening up. So when I find my vertex, it is a minimum value. I can go ahead and tell you the domain's all reals, and I can go ahead and tell you the range is going to be from whatever y value, this vertex, whatever the y value comes out as, and it's going to be included, and it's going to go up to infinity. So I know that much, but I need to figure out what that y value is. So I'm going to go back to my whiteboard here. All right, so I'm going to take negative b, which is negative 20, so negative b over 2, and then a is 5. So that's positive 20 over 10, so that's 2. That's the x value. So now I plug that back in. And do my calculations. So 2 squared is 4 times 5 is 20. 20 times 2 is 40. 17. So we've got 20. So we've got 37 and negative 40. So that's negative 3. So my point is at 2, negative 3. So I'm going to go back to my table and fill that in. So that's the y value of the vertex that we were looking for. Okay. So really, if you understand your transformation rules, the only ones of these that I had to do some algebra for were those quadratics in standard form. When they're in the vertex form like this, like the most you have to do is like setting the inside or the denominator equal to 0 and solving for x. But other than that, it's really just knowing the rules, okay, and understanding what domain and range is, understanding which functions have a vertical versus a horizontal asymptote. Okay, so hopefully you got most of that right. Maybe just a couple little mistakes here and there. Be careful with brackets versus parentheses and positives and negatives. Those are probably the most common mistakes. Or switching if it's vertical or horizontal for your asymptotes. So I would suggest reading over, going back and studying your notes. You can always go back to any of our Delta Maths and do extra problems, even if you're already done. But that's it. So this no calculator portion of the test that includes this and then some of the other stuff from the other part of the review is Monday, and the review is due Monday.